Alright, today we're going to be doing area. We've already done volume. Area is a lot simpler. I'm just giving you the notes on it, so you can take these notes however you want to. I'm going to ask you to do a foldable later, so take good notes, that way you can do this. Area, you already know area is the amount of space inside a two-dimensional object or shape. Okay, 2D, something flat on paper, doesn't have that third dimension, doesn't have that depth. Okay, so we're going to go through some of the figures and shapes for area. Your first shape, a rectangle, is a two-dimensional object where the opposite sides are congruent, and then there are four right angles. So as you see here, draw a picture of a rectangle. My sides opposite from each other are congruent, and I show that by these tick marks. And then on the other side, the other two sides are also opposite from each other. They are also congruent. And then on the inside, I have my four right angles here. Okay? So that shows that I have a rectangle. The area formula for a rectangle is simply length times width. Most of you probably know that one. That was an easy one. A square has the same formula because a square is a rectangle. A square has all sides congruent, but it has four right angles. So the square formula is going to be the same, length times width, or side times side. Either one will work for square. So this is the area rectangle formula. Okay, so that is rectangle. Next one we have is a circle. A circle is a two-dimensional object where every point is equidistant from the center. This is very similar to a sphere. A sphere was a three-dimensional object that looked like a circle. Here we just have a circle. Every point is equidistant. So every point on the outside of this is the same distance from the center. And I've shown that I have a diameter that goes across, and then I have a radius, which is half of that diameter. So if you didn't pick up on that from the popcorn activity or from the word problems, hopefully you picked up on that by now. The formula for circle is pi r squared. Okay, very easy. Area is equal to pi r squared. So you take your radius and you simply square it there. So that is the circle formula and definition, and then draw a picture to help you remember what is what. The next shape we have is a triangle. Triangle is very easy definition. It's a two-dimensional object that has three sides. Okay, there's several types of triangles. We'll get into those later, hopefully. If not, you'll definitely see it in Math 2 and Math 3. Okay, so draw a picture of a triangle. The formula for a triangle is 1/2 base times height. So you have your base. The base is always the bottom side of your triangle. The height goes from the top vertex to that base. Okay, so the height is always going from the top vertex to that base. It's not one of these diagonal sides. Your height will always be perpendicular to your base. So make sure that you show that little right angle block that you have on, I'll just do it here. Make sure you have your little right angle block there to make sure you know that the height has to be perpendicular to your base. Okay, so that is 1/2 base times height. That's where I get my height, and that's where I get my base from. So that is a triangle's definition, and then its formula. Okay, the next shape we got, I believe, is a trapezoid. This one is kind of tricky. Some of you will probably have the hardest time remembering this one, but that's why I'm giving you notes so you can study them. A trapezoid is a two-dimensional quadrilateral. Quadrilateral means it has four sides. That has exactly one pair of parallel sides. Okay, so your parallel sides are up here, and I did not show this, but it would look like this. If I had parallel sides, you would have arrows going in the same direction to show that they are parallel. Okay, so if you draw a picture of a trapezoid, make sure you have your arrows on the top and the bottom. I've labeled on B1 and B2 because in my formula, they're labeled B1 and B2. I also have a height, which is the same as perpendicular to my base. Okay, so I don't have that box again, but you know that the height will be perpendicular to the base, similar to a triangle. The formula for a trapezoid is 1/2 times the height times B1 plus B2. So you take your top side, your bottom side, you add them together, and that is what goes inside these parentheses. And you multiply that times your height, and take 1/2 of that. Okay, so that is a trapezoid's definition. Draw this picture, make sure you have everything labeled, and your formula. This is the most important part that you'll need. Alright, so there are your shapes. We're going to do some examples really quick. Something very basic. This is nothing compared to volume. Okay. Number one, you have a rectangle. Your sides are 9 and 7 inches. Use your formula, length times width, plug them in. 7 times 9 is 63, and then I have my inches here. Inches for area, my units, make sure you have your units labeled. Make sure you have a square. Square is two-dimensional, so your exponent should be a 2. In volume, we had 3 dimensions, so our exponent was a 3. Here, our square needs to be on the end of the unit. So the area was 63 square inches. Okay, so I could fit 63 of these little square inches inside this rectangle. That's basically what the area is telling me. Okay. Next, number 2, we have a circle. We have the diameter of 10 meters. The circle formula was pi r squared, but I don't have r, I have the diameter. So you're going to take that 10 divided by 2, that's going to give me a 5, and that's where this 5 comes into play. I put that 5 in for my r because my 5 is my radius. 5 squared is 25, and I just don't have a calculator, so I'm going to be leaving my pi on the end of it to know that this pi does still have a value. So my area is 25 pi square meters. Again, my area I have to have in 2 dimensions, so this is a square. Okay, then the last one, number 3, is a triangle. I've told you that the height is 3 centimeters, and the base is 6 centimeters. So I'm just going to use my formula, 1/2 base times height. You have 1/2 times 6 times 3. That gives me 9. My units were centimeters, and then I have square because, again, it's area, not volume. So make sure you have that 2 there, not a 3. Okay, then the last one, number 4, is probably the hardest one because it is a trapezoid. And again, if you don't understand any of this, go back and watch it at home. You can, or rewind it, and you'll pick up on it, hopefully. If you don't, come see me, ask questions. I got a trapezoid here. I have a base, and a height. Your trapezoid formula, 1/2 times your height times b1 plus b2. Okay, so basically I look at my trapezoid, what do I know? I know the height is 8 inches. I know my top base is 3 inches, and I know the bottom base is 5 inches. So then you just plug it in. Plug in 8 for h. B1 was, well, it should have been 3, but I remember addition doesn't really matter, so I have it backwards. But B1 I said was 5. B2 is apparently 3 now, so it doesn't matter, just add them up. 5 plus 3 is 8. 8 times 8 times 1/2 is going to be 32, and then my units were all inches, so I have that squared. Again, this does not matter inside the parentheses because it's addition, and addition can go both ways, okay? Just like multiplication. So as long as you add up what's on the inside, then you multiply, then you're good to go. So our area is equal to 32 square inches. All right, so those are 4 basic, easy examples. I just want to show you how I would want them done and how I want to answer, so you don't have any questions when it comes to classwork, quizzes, or tests. Again, they're not going to be this basic. They will be given in word problem form. What you're going to do today, I'm going to show you, but I'm not going to show you all the way through. I'm going to give you 4 points, and the activity today deals with perimeter. You all know what perimeter is. We've done some work with that already. And area, which we just went over. Okay? You're going to be given 4 points. From these 4 points, your shape may look like this. It may not. You may have 3 points. You may have 5 points, depending on what you get. It probably won't be 5. But depending on what you get, you are going to graph those 4, 3, or 5, 6 points onto a piece of graph paper. We'll give you graph paper. Once you graph them, I want you to connect those 4 points, or however many points you have, connect them, because that's what you're going to find the perimeter for. Okay, so you're going to find the perimeter along the outside of those lines. Once you connect your dots together, you're going to find the perimeter. Now, the way you find perimeter, you can use the Pythagorean theorem, or you can find the distance. You're going to need to find the distance between each point. Here, I would just take the Pythagorean theorem, go up, over, so you have a length and a length. You have 3 here, you have 1, 2, 3, 1, 2, 3, 4 here. So 3 squared plus 4 squared, that's going to give you the distance here. Okay? So you use the Pythagorean theorem to find this length. Once I have that length, do the same thing for this one. Do the same thing for that length. Do the same thing for that length. That's just part 1. Part 2 is going to find the area of the shape that is inscribed. And the way you get your inscribed shape, you're going to take the midpoint from each point. You're going to take the midpoint from one point to the other. You're going to find that middle point. And you're going to do that for each line segment. Okay, so you're going to find the midpoint for each line segment that you just found the distance for. Once you find that midpoint, you connect the midpoint locations together. And I've done that with the dotted lines here. Okay? For this inscribed shape, because it's inside my other shape I have here, I'm going to find the area of what I just shaped. Okay, so you're going to have to do the distance formula again, or do the Pythagorean theorem to find these distances. Okay, once you find these distances, you're going to find the area of this shape, and it should form a square. If you have a rhombus to start with, it'll form a square. So you're going to find the area given the shape. And I know it's a square because my lines are perpendicular here. So you can do length times width. And if it's a square, all the sides are going to be the same. If it's a rectangle, these two sides are going to be different. These two sides will be different. The opposite sides will be the same. So you have to determine, based off of the definitions, what this shape is, and then what type of formula to use to find your area. So I'm looking for two things. Part one, you need to find the perimeter around the outside. Part two, you're going to find the area of the inscribed shape. Okay, so that's what you're going to do right now using your formulas and your definitions.